Good afternoon. This is the third peering forum session. We're going to start in a bit, probably wait for 30 seconds more for people to come in. But giving a quick intro, the next speaker will be Julio, and he's going to talk about 400 ZR. Thank you, Julio.
Thank you. Well, today I will talk to you about our experience in IXBR in Brazil, about the technologies that we use, and the changes that we have to made in the last 7 years. I think the motivation on my side to prepare this talk is to share what we see, and also expecting that maybe in the future other companies can do the same. So this is the network that we have in São Paulo. We have topology is like a double star, and we have 2 central points, and we have 30 data centers in the metropolitan area of São Paulo that are directly connected to these 2 central points. The agreement we have with these data centers, they offer to us space and power and dark fibers to both of the central points. And we provide the network equipments and the network for optical transport using the dark fibers they provide. And in the counterpart, they can charge for cross connects to reach our equipments. This is how we operate this kind of network. This is a big network. We have about 150 network devices here. So let's start talking about the history that I want to share with you. It started in 2016 when we were using switch and router based on 10 gig ports. In 2016, we reached the limit of this technology, where in the fiber, as each data center provides us 1 pair, the limit were 40 channels of 10 gig, about what gives us 400 gig. And it was not enough. So we have to make an upgrade, we have to scale and move to another technology. What was good at that time that we was using colored DWDM transceivers that was connected directly to the routers and to the DWDM multiplexer. It was very easy to work, and the optical part was, we can consider it cheap in that time. Just to remember, in 2016, the traffic that the network was running was about 1 to 2 terabits per second. In 2017, we bought new equipments. We have to change the central points switches. We moved to new boxes with based on 100 gig ports, and start to using an equipment that we call DCI. DCI means to data center interconnection, and this is a concept, but it's a box with transponders. When you connect to one side 100 gig ports, on the other side you go to the line. And we started with an equipment using 200 gig per lambda in the in the fiber optic. During the time, we decided to change the vendor of this DCI equipment, starting to buy from a second one. And at the end of this DCI era, as we can say, we moved to an equipment that use 400 gig per lambda in one rack unit. And at the end of this period, from 2017 to 2022, we have installed 58 terabits of optical transport using this technology. The next step was, okay, we reach another limit. The limit was the number of ports that the switch and the router that we have was in the limit to have maybe 95% of its capacity in use. So we have to move to another equipment, and the only option was to move to a network equipment with 400 gig ports. And together with that, we decided to change the optical transport to moving to transceivers with the 400 ZR technology. This is the two equipments that we on the left side, what we were using, the one based on only 100 gig ports. We have available 288 ports, and the power consumption of each port was about 25.6 watts. And the new model is a bigger one with capable of 16 line cards, and these line cards can support 100 gig and 400 gig ports. And the power consumption depends on how many line cards and what kind of line cards, or even the line cards that have 100 gig and 400 gig ports, how they are populated. And you can see in the column that watts per 100 gig, the consumption. Now I am starting to talk about prices. Okay, price is a very sensitive matter. I cannot disclose price because it's under NDAs. I can't say how much we pay for each device, but what I'm trying to do is to make a relative price. So I choose one value, and I set it to a value of 100. In this case, is in October 2022. And the prices after that date of later, they are relative. So we can view if the price has increased or not. So in terms of the network equipment, when we bought the equipment in 2017, each 100 gig, the cost was probably 2.5 times the price that we have in October 22, when we populated the new equipment with 100 gig ports and also 400 gig transceivers. On August 22 is the exactly moment when we make the transition without the 100 gig the 400 gig ports. We can see that the price was a little higher than with the older equipment. The prices for the future from 23 ahead, it's a provision on how we're gonna fill the equipment and use the resources we have. So in July 2027, we expect only to have the equipment populated with 400 gig ports. This is the scenario of the optical prices. So we started with the first vendor in between 2017 and 2019. Moving to another vendor, we can see in the first dashed line that we have a better price. It decreased a little, and in 2021, between March and August, we see the prices increasing. This is because of the pandemic and the problem with the semiconductor industry, that the prices of all vendors have increased. In February 2022, it's not February, I think it's, okay. We bought the 400 ZR transceivers, and we can compare the price of each 100 gig with the 400 ZR transceivers versus the old technology, the data center interconnection. So we can see that 100 gig in the old technology is almost 4 times more expensive than with the new model. The use of the data center interconnection equipment, it demands more other parts, like 2 transceivers to connect the network equipment to the transponder, also a cord with MPO connector with multimode type of fiber. And the 400 ZR is a little more simple. We only need 1 connection to the multiplexer. So in this chart, I can show the evolution of the price of the 100 gig transceiver. In this case, it's the SR4 model. So this is the important point that I wanted to reach. This where I can gather all the information about the technologies in use. When I have the cost of the network equipment, the cost of the optical transport, cost of the transceivers, and the cost of the power to have each 100 gig working for 5 years. This is the reference that we are using in this study. Because we believe that each 5 years we have to change the solution. So what is most important for me in this result is that not only the price is much less, much cheaper than the old technology, but the difference of the composition of the price. The optical part was a very, it's bigger than the cost of the network equipment. And sometimes this is not desired. So now we have a more equilibrated solution. The other objective of this study is to permit that, to look for the evolution. In the morning, we could hear about 800 gig, 1.6, 800 gig, 1.6 gig. And this is probably the next evolution we will have to face. So with this data that we have collected, we created the model. So to make a decision to what to do next, it will be easier if you can fill the spreadsheet or something else with the data that of the new technology, and we can compare with what we have. In an operation like we have, space and power are very important. Even Nick Bjarne, the company that runs IXBR, have these 2 data centers in the center of the network. We are clients. We have limitation of space and power. And it was very difficult for us to make this migration because the power is limited. And it's hard to replace an equipment that consumes more than 10 kilowatts. And sometimes we cannot turn both of the equipments on together. Another comment about the 400ZR technology is that even we've been using such a optical layer since 2016 or even earlier, and we did not change it. We can use the same optical layer. They are compatible with the old technology, so we can only change what we insert into each channel in the WDM system. But we know that the technologies are different. The data center interconnection that have they are not the signal to noise, the optical signal to noise relation to the 400ZR is much more sensitive than the DCI. So we have some concerns about how many channels we will be able to insert in this fiber. Another point is that nowadays we are using 2 vendors of these transceivers, and informations about the operational status they return are different. They don't have values that we can compare both of them. Okay, this one is working better than other, or how is the situation of the fiber? How is the signal to noise? How is the operational limit that we have to insert more channels? So this is some operational conditions that we have to check, and we are making some labs, some tests to discover it. In terms of the 400 gig ports, nowadays we have just 1 port connected to 1 participant, and we are both sides are validating this technology. It's the first from our side and also the first on the other side, because it's hard to find places to connect this new technology in production. I know that probably for many of you, 400ZR may be not achievable in a short time frame. But it's important to understand that we have choose this technology or even the data center interconnection because we need this in volume. And there are many other options. So it's important to look at optical white boxes. We have open packet transponder, we have MUX ponders. That's an equipment that you have on one side the 400 ZR transceivers, on the other side 400 gig ports. That it's interesting to analyze. We have even all the DCI manufacturers are building transponders that use the 400 ZR transceiver as the optical for the line. And the QSFP 2800G coherent transceivers. This is a very important option that you can send 100 gig for a long distance. And if you need to send more than 100 gig in the fiber, you can use a multiplexer. Okay, this is what I wanted to share with you. The idea is to disclose to the community part of our history in terms of these technologies. And if you have questions.
Thanks, Julio. We have questions. Do you want to ask them questions? We can swap it.
Probably they don't understood anything, but no problem. If you have any questions or doubt, I am around and can talk to.
Oh, we have a question.
Yeah, a very good afternoon. So I just wanted to check at the optical layer. May I know if there were any changes, like, because I'm sure previously you have used things like amplifiers, preamps, boosters, and maybe even optical protection switches, or they just work perfectly with your optics?
We didn't change anything at all. It's compatible with what we're using, and and until now we didn't have the necessity to change the optical layer, but we are aware that maybe the amplifiers may be problem depending on the signal to noise figure that it has. But nowadays we don't have a lot. We have DCI channels plus 400 ZR channels in the fiber. We are going to remove the DCI channels that we still have as soon as we can get new equipment from the manufacturers, and now we can see how it will behave.
Okay, thank you.
Thank you so much. One more call for questions. If none, we'll thank Julio. But before you go down, please accept this special token from APRICOT. I have a photo from Masatakasan. Yeah. Thank you, Julio. Our next speaker, talking about RPK and ROA updates, calling on Masatakasan. Round of applause, please.
Thank you for introduction. So, my name is Masaka again. So, I like to talk about the RPKI, and this talk is for network operated by ISP over CN, DCDN, context providers. So, its talk is for IXP providers, engineer team member. Engineer people. So, yeah, first of all, I like to introduce about RPKI itself briefly. So the RPKI become popular as a infrastructure used of certificate of assignment and allocation of IP address and AS numbers. So the RPKI is based on some documents. The RFC 3779 is one of documents related to RPKI. So actually, so RPKI is deployed in the network operated by ISP and other network providers. So in this presentation, the not only a network as the owner of AS and but also IXP are operating network. So in this presentation, the network is called IX segment. So as I mentioned, the RPKI and issuing ROA, deploying ROV is globally used in our industry. So but the IXP is running network as a IX segment. And the IX segment is important thing for as a peering platform. So there are so many eBGP sessions over IX segment. So and IX segment also should be protected from trouble due to misorigination of BGP. So that I think IXP need to consider about ROA legislation for IX segment IP address. So as I mentioned, RPKI issuing is needed for IX segment, and I have surveyed the status of RPKI ROA registration for IXP in Asia Pacific region and some IXP in European region. So as you can see, the result of survey is inconsistent. So it lacks of the sense of unity. But as we can see, so there are two types of result. So the one type is ISP has already have registered RPKI ROA. And the another type is the IXP doesn't have RPK ROA yet. So, and in terms of the information of ROA, so the this result of survey, so the consists of three information: the prefix length and the maximum prefix length and S numbers. So the some IXPs has used S0 or for ROA, and some IXPs using their own S numbers. So there is IPv6 ROA survey result. So it's almost same as IPv4 or ROA survey. So but the none in ROA law, this means this IXP doesn't register ROA. So the number of non of ROA is more than IPv4. So it's a summary of my survey about the ROA registration about IX segment. The first point is about prefix size of ROA. So there are two types of registration. So the one is exact match prefix size, and another is larger prefix size. And the second point is about maximum prefix length of ROA. So it's same as first one, prefix size of ROA. So there is a exact match equal with prefix length between prefix length and the prefix size. So and third one is about S number of ROA. So as I explained on the previous slide, so there are two types. The one type is using S0, and the another type is using your own S. So I explained about ROA S0. So I like to explain S0 ROA on this slide. This explanation is on RFC 64083. So basically, so S0 on RPK ROA is not used for prefix on the routing context. So in other words, so if there is a prefix on the global routing table, so they should not use S0 for RPK ROA registration for the prefix. And this diagram shows preventing trouble by misorigination of IX segment. So on this slide, the 4 ASs, the AS number 64500, 64502, and 64503. So the three AS network doing misorigination of the IX segment. But if your AS has proper route filter by using a prefix size, so they can prevent trouble due to misorigination. So the configuring the route filter is still basic and standard configuration. So it's still necessary for us. So, but I think it looks like the relatively legacy. So this diagram almost same as previous slide, but there is some different from previous slide. So if your AS has deployed RPK ROV on your AS border router, and if IX register RPK ROA for IX segment with AS0 and proper prefix size. So this model also can prevent the trouble due to misorigination by BZP. So the important thing is correctly issuing ROA for IX segment. So this helps prevent troubles caused by IX segment misorigination. So this is the conclusion slide on my presentation. I'd like to conclude this presentation by this slide. So I have 4 points for concluding this presentation. The first point is as you see result of survey of IX segment ROA registration. So there are widely variation type of ROA IX segment already issued. So, and second point is if your IXP didn't issue, so please issue ROA with using AS0 and a correct value of max length. So it's not only for IPv4, but also IPv6. And third point is if your IXP already issued ROA RPK ROA for your IX segment. So please check again S number and max length on your ROA. So if the issuing way is not proper, so it doesn't work correctly. So, and the final point is correctly issuing ROA helps to secure our internet routing. So we hope RPK ROV will become more deployed as well. So that's all my presentations. Thank you for your attention.
Thank you, Mr. Takasan. Do we have questions? Or do you want to ask them questions?
If you are IXP, please raise your hand. Thank you. So oh, there's no slide. So
It's back.
Yeah. Yeah, I have surveyed current situation of RPK ROV, ROA So please check on the situation of RPKI ROA situation. So if issuing is not yet, so please do it. So later. Thank you.
Thanks, Pastor. Relaying the message. Do it. Yes, Julio?
Yeah. No, I think this is a very good practice to issue a ROA for the prefix block used by the IX. But I think that in your picture, you are protecting your network. But I think the idea is to avoid that the block of the IX be announced in the internet. So maybe you have to consider more connections to the network connected to the IX, and they are announcing this block to their upstreams or other connections. And this is where the block must be blocked, because if not, for example, someone that received this block can start a denial of service or something else, sending package to a router inside the IX network.
Yeah, so as I explained my slide, so the configuring route server is good solution for trouble due to misorientation. But additionally, so if RPK ROA on IX segment is issued, so if the network size of IX segment will change, the network filter by using RPK ROV is automatically changed. So it's one of advantage of the filtering by RPK ROV, I think.
Oh, okay.
Thanks, Julio. Are there other questions? Oh,
Maratari-san, is there any existing hijacks when facing the problem of the IP address ROA that have to use your method to protect the hijack?
Actually, so I didn't have trouble due to hijack of IX segment. But the JPIX IX segment size is 24 in Osaka and 23 in Tokyo. So I think so. There is a less possibilities of trouble happening. So there is no real trouble, at least in JPX Tokyo now.
Okay, thank you. Thank you.
thanks again, Masataka-san. If there are no more questions, I will keep you something. Speaker token. Thank you, man. So ask somebody to take a photo. Where is there?
Thank
Thanks
you.
again, man.
Thank you. Thank you, everyone.
Our next speaker is Anurag, your foreman.
Thank you.
So good morning, everyone. My name is Anurag Bhatia. I work at Hurricane Electric. We operate a global IP backbone. Let me get my laptop connected to the Zoom here. This is the first time I'm doing this live presentation and putting slides over Zoom, so kind of interesting. I'm going to share my screen. So I got a rather more complicated setup so that I can do the live demo. Okay, this should work. And probably go and do the slideshow. Okay, and I have got the pointer. Okay, this works. So yeah, good evening. I won't be taking much time. This talk is about managing your IX route server just using Git. I'll take a first few initial slides to explain the problem, and then most of the other slides would be around the possible solution. So this is the intro slide. I'm going to skip that. So why we cannot handle route server configuration of an exchange by hand? Well, there are a couple of challenges in managing route server configuration. One should be able to filter members. At this point of time, you don't want to run an exchange route server where you don't filter members. You want to have a setup where you are able to update configuration at regular intervals, because if you filter by hand, you cannot regenerate that easily. Most of exchanges, anywhere, as they cross a very low threshold of say 5 or 10 members, it becomes hard because you got a large config to write by hand. And in majority of cases, exchange would be running at least 2 route servers with identical but not the same configuration. Why I say identical is because in majority of cases, you'll have route servers running with same set of peers, same set of prefix filters, but different set of router IDs and a couple of other things. So this is a challenge which this presentation talks about, how you can solve the problem of managing route servers by hand. I introduce you to a tool, a popular open source tool called ARoute Server. I've talked about it in past. It's a pretty good tool. It can generate a route server configuration. It is written in Python. It supports Bird as well as OpenBGPD configurations, and it supports filtering based on route objects as well as RPKI ROAs. So the previous version of Bird, which does not support RTR protocol, it can generate static filters based on the RPKI ROAs for them. And with the newer version, of course, you have the RTR support, and you can connect it to a validator. For IRR, it's the same old school. You go and resolve every member's AS set. You figure out their AS set if they have one from the peering DB API. Then you put out their prefix filters. You ultimately put them in place, and then have the configuration ready. It has a dozen of good to have filter rules built in. For instance, it by default would reject routes which have transit-free ASNs. I know many networks who would deploy ARoute servers and reject the local large ASNs. So if you are running an exchange, say in Manila, there's a possibility that you may not have a small network announcing you routes of say PLDT or Globe. So you typically have those large ASNs filters in there. So you reject them. It supports BGP communities and information based on that. So it supports basic features like don't announce my routes to other member, or prepend the routes to certain ASNs, and as commonly you would expect. Now, there are a couple of challenges with ARoute server. It solves many of the problems which I mentioned in the first slide, but it needs light Linux administration skills. You need someone to log in, to set it up, to re-trigger it. If you run it automatically through a cron job, then you are at a risk of it failing silently. So you need some mechanism to throw an error, to track the errors. It needs some basic steps to update clients.yaml. I have helped out a few exchanges which use ARoute server and have found problems when they update clients.yaml in a Vim-like client. They would break the YAML syntax and the tool won't work. It lacks the view of logs if you are triggering it automatically in a traditional setup. it builds the it is hard to automate it, as I said, in the absence of any wrapper around it. So this brings me to the actual talk for the day, which is about using GitLab CI/CD pipelines to have a system where you manage entire route server configuration just out of Git. No other tool around, just have the Git, just have your members sitting in the Git. You commit the members, it goes and deploys the config, it goes and actually pushes the config. And you can have any sort of extra checks in there. So I'll demonstrate that in a minute. Basic idea of Git, if you're not familiar with the Git, it allows you versioning of code. So Git as well as CI/CD pipelines come from the developers world. It's very mature ecosystem, but because it's so mature and it's so popular now, we can use that in network engineering domain and make use of these good advanced open source tools. It allows you creating of branches, so you can have different branch to test out. In theory, you can have your configurations running with a master branch or a main branch, and then you can have a developer branch where you test out, generate config, verify things, and then just merge that out in the master branch. It allows you to work locally, push things in the remote. In past, there were some other alternates, including CVS, SVN, etc. Not going in there. Now, what is CI/CD? So that's again a concept coming from the software world, which is about continuous integration, delivery, and deployment. Broadly, it talks about with continuous integration, it's about you have some actions which are triggered as soon as code is pushed. So this is taking us to the point where you push your client's information in the clients.yaml, which is used by a route server, and some action can happen. It allows you to test and allow commit only if certain tests are passed. So you can have some checks and balances in place before you just go and break your production route server config. It helps to have basic checks and management, as well as any sort of upper layer checks in the workflow. What is continuous delivery and deployment? Again, I changed the slide. It's disconnected. Okay, probably little latency. So it allows you to build test deployment on the Git commit. So besides running those tests, you can actually have a system where it goes and deploys the code. Again, these tools are coming from the software world, so there are tons of features. We can just use a couple of those interesting features to make it work. It can these deployments can be automated or manual, or could be a mix of that. So you can have a system where you are testing out configuration in the route server, you make a change, it deploys it immediately on your dev environment. But before it deploys on the final production environment, you have an extra check in there. So that's useful. Typical use case, you have code pushed, test environment is built. So you can even have a system where there are no route servers for test environment. You actually create route servers, test the config, and then kill those route servers and ultimately deploy the final output. That can be a basic typical use case for such environment. Well, why you want to have this complication? If you're wondering, why have GitLab to actually manage it if you can just do it with a route server? Again, it makes deployment easier. So you have some checks and balances in place. You can have different branches in place. It makes the initial setup as well as long-term management easier. And this is especially true when you'll find many of the internet exchange infrastructure people not being very familiar with Linux. They might be familiar enough to go and log in and make some changes, but they may not be very familiar to maintain it over a longer periods and work out with errors and so on. It gives you automatic configuration flow, so low chances of mistakes, supports the basic IRR and RPK filtering, and you can even abstract the IX management because GitLab itself offers you REST API. So you can have these jobs triggered through a REST API call. You can even pass variables in REST API. And as a matter of fact, just before this talk, last week, we did the workshop on network automation, and we built out certain cases with respect to GitLab. So you can automate any sort of thing. You pack any sort of thing in that, and you trigger it through the REST API call with any sort of variables as you need. You can make use of good tool, as I said, a route server, or you could have any other a route server like tool if you want to have. You have your own custom scripts, so you can actually port those custom scripts in this workflow rather than triggering them over a specific predefined server. So what's the end goal here? if you may ask? Well, end goal here is to have a simple clients.yaml. I just put this as a test case, and this is the clients.yaml I'll be demonstrating with. So this is just 3 peers. Let's say I got one peer as Google 15169. I got a peer as Globe, since we are in Philippines, and I got my AS number 6939 in here. I put only 3 because it takes time to generate configuration. I tested out configuration of with over 200 peers. That was the case for DECX Mumbai. It takes anywhere from 3 to 4 minutes to do that kind of thing. For just 3 members, it should not take that long time. I didn't want it to, do a demo where you wait for 4 minutes here while I stand here. So you get this sort of basic clients.yaml configuration, you update the IPs as you need to, and you just commit the code. That's the end goal. Everything else should be automated in the background, whether you have one or more, or route servers running in different location, all that can be automated as part of the workflow. This brings me to the live demo. So I'm going to exit the slides for a minute. I have one more slide after that, but I'll exit the slides for a minute and we'll go to the Git project. Keep in mind, all these tools are open source. You can use hosted Git, or you can have your own self-hosted Git. Give me 1 second. I think it's interesting. I have Zoom stuff blocking me while it's not visible here. Okay, so this is the project I have. This is just a demo project, and the link is there in the end of the slide, so you can go and check it out there. All I have got is a GitLab CI file. This is the core of CI/CD setup. So I got 4 stages in here. One is I build out a Docker container, which is taking care of all this part. So that's the Docker container, which is going into the route, which is going into the server and deploying it. Then I got build RS stage. This is essentially building out the route server. That's just making sure that the bird is there and all the prerequisites like getting the bird repositories there and so on. Then 3rd and 4th stages are the one which we would be running very often, which is to generate configuration for the members and pushing the configuration. First 2 stages are something which you may do once in a while, not regularly. 3rd and 4th stages are the one which you may want to automate and do it every, say, 4 hours or 6 hours, whatever works. So the first stage, Ansible build, we are just using Docker image here and doing the basic Docker build command. This image has nothing much other than just a basic Ansible in there. It's just building out an Alpine image with Ansible. That's it. Next is the build RS command. Here we are simply calling route server, a playbook to call to set up route server. The first few commands here are to make sure that the SSH key is there. So we provide the SSH key as an environment variable to the tool, and that the private key is provided to the tool, and the corresponding public key is already there on the servers. You do the same thing, so it's replicated to RS2, and then the final part, which is we make use of the official route server Docker image, and we provide various things to environment variables. Take, for instance, this case, we provide the route server version, we provide the client.yaml and other things, and it goes and builds the config. So how it looks like in practice, let me show you. So let me open one of the route servers. So this is one of the route servers. This is I'm logging into the server for the first time, just a demo server. It has got nothing in there. All it has got is just Ubuntu 20.04. Even bird is not installed in there. Just to be sure, I'll do a ls. I think I should probably type by single hand. So I do ls/bird. So bird is not installed in there. So let me trigger the whole build without doing anything manually in here. So I'll go to the pipelines. Now, whatever I'm doing from the web interface can be done at a schedule or can be done through a REST API call. I'm doing it from the web interface just as a part of demonstration. And one can even have a setup where the pipeline is triggered when clients.yaml is updated. It would be even more interesting. So this triggers the pipeline, the first job. So I'm not building the container here just to save on the time. I already got the container with Ansible built in. That's a step you would do once in a while, once maybe in a few months whenever you want to upgrade the Ansible version, essentially. So it is building out both the route servers. I can even say show me the dependencies. So each of these jobs have their own dependencies. So we cannot push the config unless, we cannot push the config unless the route server is already built, and we cannot push the config unless the config actually exists. So this is making sure bird is ready, it's there, and all of the dependencies are there. This is to generate config and keep it locally, and then in the next step, push it to the remote. So this is the one making use of our custom built image with Docker. This is the one which is making use of a route server image. So route server 1 is ready, other one should be ready soon. This is just making sure bird repo is there and bird itself is installed and a couple of other things. The playbook itself is public, so feel free to check it out later. So while it's building out, I'll probably take a minute and go in there. So I go to the route server 1 task. It shows me output right here. This can be shared with my team. Let me probably zoom in a bit to make it easy to read. And somehow the text is being garbaged out here. But essentially, this is the idea. On top right, you have 55 seconds, which it took for this job. It runs on a runner. That runner can be anywhere in your infrastructure. Runner is just taking these containers and doing these jobs. You don't need to have runner in your infra. But runner should be able to speak to your route server. So if your route servers are only on a private IP, you need to make sure that the runner has a reachability to the private IP. I go back to this jobs. So it is still building the route server config. I'll wait for it for a minute. In meanwhile, I'll show you the variables. So I've defined the variables, including the exchange itself, the exchange prefixes itself, as well as other thing as part of variable so that we don't hard code it. So we provide the bird version as part of variable here. This is just being provided to it during the runtime. If I need to update it, I'll do it here, and all the route servers will pick that. You provide the local prefixes, local ASN, and it also needs PeeringDB API key. You can, in theory, do it without the key, but PeeringDB heavily rate limits the GET request. So if you try to contact PeeringDB to generate config maybe more than 2-3 times in less than an hour, it is going to rate limit you. So it's good to just put the API key if you have a PeeringDB account to avoid that rate limit. Also, you provide the SSH private key. So this key sits on the tool, and this is provided to the container during the runtime. If you're not comfortable with, say, hosted Git with your private key, you can self-host it. You can have it all hosted within your infrastructure. So I'll go back to the pipeline. Hopefully that should be finished by now, and we'll see. Okay, so it just passed. It took around 2.5 minutes to finish this one off. So it generated the config. I can click in here and just demo you the output. It's still garbaging out the output. So essentially, it goes through each ASN in my list, contacts PeeringDB, pulls their AS set, expands them, generates the config, and so on. So you see Google in here as was part of our config. You have 4775 globe, and that's RASN AS693 in there. So it expands them out and pushes the config. If I go on the route server now, where we did not have the bird earlier, we have got 3 files in there. I can go and get the bird config just to demonstrate. Bird.conf. So this is the old version of bird. So you'll see bird and bird 6. So one for v4 and one for v6. This is the configuration it automatically generated. It would have a large list of ROAs. It is putting ROAs as a static filter in there for the older version, and I will keep updating it whenever I run the pipeline. If I'm doing it in production, I'll probably remove the manual triggers. I'll rather have it configured to say, whenever clients.yaml is updated, do this rebuild, and also do this rebuild every 4 hours, right? So if any of the member add an AS set in their ASN, add a downstream, the filters would be open automatically in 4 hours or so. So that's the use case. With that, I think the demo completes. I'll go back to slide. I got one more slide to go. So possible checks and automation use cases you can have things like, as I already said earlier, you can pass it to dev route server. In this case, I demonstrated to you with 2 route server in one final deployment. You can have any sort of extra checks in there. You can have another dev layer before you actually push. You can also have it to generate a website. So you will find website building tools which can read a YAML file and generate member list. So it can do that. That can provide you a full ecosystem alternate to IXP Manager, which is, by the way, a very good project. But at the same time, at times you may want to have something more simpler rather than having IXP Manager to do it all. It can even send an automated mail to mailing list. You can just have a script in there which will pull the member name or just do a diff on the commit and pass that member name saying, hey, a new member is added. This is the AS number. This is the contact and so on. You can do a config rollback, and you can even say to your NMS, keep an eye on the traffic. If traffic drops below this part, do a config rollback immediately. Probably someone screwed up something or so. So that sort of automation cases are possible. You can even have it to inform team over Slack, Telegram, or so. These kind of updates you can get from the pipeline itself, or you can even have an NMS to trigger that sort of updates as per the use case. So that's broadly the idea here. Important links, as I said, the code which I use for this demo is out here, including the Ansible playbooks, pretty simple ones, and the AirOut server. This is the AirOut server project from PeerKey. Very good project, very useful. And the overall GitLab CI/CD documentation, quite heavy. Just keep in mind it is coming from the developer world, so the use cases are way more advanced than what I'm demonstrating here. Any questions, feedback, or suggestions? Thank you. That was fast.
That was fast. So one more time, any questions?
I get the chance to ask question now.
Yeah, go ahead.
How many people sitting here are running an internet exchange? Can you please raise hand? Okay. How many of you are filtering based on IRR and RPKI? Okay, that's good. Thank you.
Thanks again. Before you go, something for you.
Thank you. Thank you. Thank you. Thank you.
Thanks again, Oreg.
You need the mic?
So we go now to the last part of the peering forum. We go to the peering personals for data center, transport, and I would like to apologize if we missed some slides earlier. So we'll follow this sequence, Petra. We'll call you later. So if we can request the data center personal representatives to please queue up at this part of the ballroom. And my colleague Marlon will moderate the session.
Hello, good afternoon. For this session, we are focusing on data centers and transport network provider. First on the list is Tokyo Shaw.
Magandang hapon po sa inyong lahat. I'm Shomonden from Tokyo Corporation. And Tokyo is a data center service provider in Japan. Then our main campus, CC1, CC2 has excellent opportunity for peering. Then on top of that, we are adding some modest footprint nationwide, like DC12 in Osaka, QC1 in Kyushu, then HC1 in Hokkaido will be available soon. Then we are expanding our footprint nationwide to support the peering society. Thank you very much.
Next, we have Chief Telecom, Wilson.
Hello, everyone. I'm Wilson from Chief Telecom in Taiwan. We are the largest data carrier neutral data center in Taiwan. We have three data center, LOY, HD, and LOY2. Yeah, I need to say the LOY2 is our newest data center and will be completed at the end of this year. And there will be launched the service at the first quarter next year, 2022. This new data center owned 20 megawatt, and we provide a very high density power rack from minimum 6 kVA to maximum 20 kVA. Yeah, we also build up a chip campus to connect those data center together. So we can easily to provide TBIX, TWIX, and our cloud connection, CCX, also internet, and IP transit. Of course, there are more than 50 AS number in that presence. So it is good time to share with you. If you have any requirement or interest in our service, please contact with us. Thank you.
Thank you, Wilson. Next, we have Digital Edge.
Good afternoon, everyone. Mabuhay. I am Katrina Pardo from Digital Edge. I'll be speaking on behalf of John Santa Ana. So Digital Edge actually is a regional data center platform across Asia Pacific. So we have 16 data centers across Asia Pacific. So we have in Tokyo, we have in Seoul, we have in Indonesia, and just recently we announced that we will be having in India. And then tomorrow, we are formally announcing that Manila Data Center, which is NARA 1, will be available for service tomorrow, March 1. So in terms of IX's presence, so for NARA 1, given that we will be launching it tomorrow, so it will just be to be announced. For the other data centers, specifically in Tokyo, we have JPIX, JPNAP, BBIX, Equinix via ComSpace. And then in Osaka 1, we have Dojima. And then for Korea, we have in Seoul and in Busan. So IX there is Kings via XL. And then for Jakarta, our IX's presence there is we have the JKIX via campus, as well as IIX via campus. We also have Open IXP via Indonet, and then we do have EPIX on site. So in terms of ASN presence in Tokyo or Osaka, Seoul, Busan, and Jakarta, so we have 30 plus in Japan, 25 in Korea, and 11 plus in Indonesia. So thank you, everyone.
Thank you. Next, we have Achi Achasa from Globe Telecom.
Hi, sorry, I'm back again. So Globe also operates a data center, but this time the updates is more of additional info. So currently we have 4 sites, but the latest one, Globe will be owning only the Cebu site, as the rest is part of a joint venture with STT. So the Makati site, MK2, Davao, and Quezon City will be a joint venture with another DC partner. For the details, you can still check PeeringDB and contact me. Thank you.
Thank you, Achi. Next, we have Sunny Vision, Tommy.
Good afternoon. Hello, everyone. My name is Tommy from Sunny Vision. Sunny Vision operates a campus of 8 carrier neutral data center in Hong Kong. And surrounding Mega I is one of our key connectivity hubs. And we have over 300 of connectivity up downstream partners within the same building, including the major IXs, OTT, CDNs, NSP, and low latency service provider, all in one roof. This facilitates the requirement of peering and all the connectivity initiatives, including all the cloud and direct connections. Also, we are home to 80% of the subsea city pop in Hong Kong. We are lucky to welcome the new addition of ADC, Asia Direct Cable, landing into our new carrier neutral subsea cable landing station in Hong Kong. We're not stopping here yet. We are also developing our second carrier neutral subsea cable landing station as well. In 2023, we will welcome 2 new data centers. One is called Mega Gateway, situated in the western part of Hong Kong, offering a direct access to a wide spectrum of end customers in the area. The second will be the core Mega IDC, also opening end of this year. It's going to be the largest data center in Hong Kong, offering 180 megawatt of power. With that completed, we will have our footprint doubled and total power capacity 400%. With all the data center interconnected with each other, we are launching also this year our new domestic subsea connecting between Mega I and Mega Plus in Hong Kong. So our customer will just be a cross-connect away with the hyperscale clusters and all the cloud and OTT and CDNs up downstream community. Should you want to need more information, please feel free to contact any one of us. Thank you.
Thank you, Tommy. Next, we have University of Guam. Jose.
Afternoon, everyone. Jose Santiago from University of Guam. At the university, we have our own data center, mostly focused around research education. We welcome other institutes to co-locate with us, maybe for data transfers or for data recovery for your storage for other universities. And we also host Marix there, the IX that we manage.
Thank you, Jose. Next, we have Vitro.
Good afternoon. I'm Jay to represent Vitro. So Vitro is owned and operated by EPLDT. Currently, we have 10 data centers across the Philippines. Then we have an ongoing construction of our largest data center, which is Vitro Santa Rosa, to accommodate more hyperscalers, co-locators. Then for the ASNs is to be announced for the exact numbers or the exact members. And here's the peering DBE data input. So thank you.
Thank you. Thank you. Next, for the next batch, we'll be focusing on transport. These are the local loop providers within the Philippines. And awesome. So first up, we're calling Wilson from Chip Telecom.
Yes, I am Wilson. Yeah, continue to the data center topic. We extend our subsea cable capacity to those cities from Taipei to Hong Kong. Hong Kong is in Mega I or Hong Kong 1. And we connect to Singapore, is SG1, and Tokyo is TY2. Also, it is great to have the hub site in Philippines, Manila, is a VM2. Yeah, those of the total capacity, yeah, it's a great news. Maybe at the end of this month, we'll extend 100 gig ESC to Hong Kong. Yeah, it's good news. And total capacity will reach to 1 tera BPS. Yeah, so that is why we need to find any solution or partners to help us to extend our footprint to other country or other cities. And the facility type is PTN. Yeah, and the bandwidth we can provide is from 10 mega BPS to 100 gig from Taipei to Tokyo. Makati is maximum is 10 gig. Yeah, and we also combine 9 different kinds of subsea cable system to build up our diverse route. Yeah. So if you are interested in the partnership or the cooperation with us and our resource, please contact with us. Thank you.
Thank you, Wilson. Next, we have from Converge ICT, Janina.
Thank you. Hi, good afternoon, everyone. I'm Janina Maika from Converge ICT. I'll be presenting in behalf of Mike Basa. So Converge ICT is located at Pasig City and Angeles, Pampanga. We are present in most of the data center or major data center here in the Philippines owned by other telcos like Globe and the, MK2 and all the Vitro sites. And we have our facility type, our MPLS and DWDM or OTN. And we offer our bandwidth services from 2 Mbps up to 100 gig levels. And we also have multiple subsea cables. We are using it for redundancy purposes. And you can always check our website for more details. And please feel free to reach out if you have any questions. Thank you.
Thank you, Janina. Next, we have Achi again from Globe Telecom.
This is the last time. Yeah. So we also manage our own infrastructure. It's covering the whole Philippines, but we also partner with other players as well. Currently, this is our main nodes in Manila, Cebu, and Davao. If you have questions, yeah, just check me out. Thank you.
Thank you, Achi. Next, we have Jimmy from Radius.
Thank you. Hello, I'm Jimmy Alcala from Radius Telecom, Meralco company. Our city country coverage is within Metro Manila and in Cebu also. Our facility is present in Globe Data Center, Vitro, DCI, ETPI, TIM, Digital Edge, and DOST, ASTI. Our facility type is OTN. We have OTN, we have DWDM, we have GPON, CEN, and dark fiber per requirement basis. Bandwidth options from 1 Mbps to N by 100 gigabits per second. We have subsea cable. So we have C2C, EAC, AAG, and ASC as well. So you could see our capabilities in our website. So if you have any requirements, just let me know. Thank you.
Thank you, Jimmy. Next, we have Rice.
Hey guys, I'm Dak. I represent Rise. So we are a local transport provider here in the Philippines. So we are present in the major data centers here, Metro Manila, and the island group is Cebu. So facility type is as follows. So carry Ethernet, GPON, DWDM with bandwidth options between 10 to 100 G. So we can connect you to and from DCs or to connecting you to customer sites. So these are the subsea cables we use. We have more info on our website. So if you need a partner to link you up to, I guess, your own customers here in the Philippine market, so reach out to us. Us guys representing Rise and the guys with Get a Fix shirts, the IX that we manage as well. So nice.
Thank you, Robert. Next, we have for the transport, Matrix.info, Clara, and as well as Safira, Anissa Firm.
Hi everyone, my name is Clara. And this is Hanan. We are from Matrix.info. We are the submarine cable provider connecting Jakarta to Singapore and also from Jakarta to Batam. In Jakarta, we are available in across 35 data center within Greater Jakarta area. For example, in Cyber One and in our own facilities, JK3, which is located in Plaza Kuningan. Also, we are located in Nongsa, in Graha Pena, and in Sumex Batam. We offer MPLS, DWDM, and dark fiber for CDN. And also our bandwidth start from 1 gig up to 400 gig. And we also, for our primary, we are using our own cable system with secondary capacity from B3JS, Indigo, and Jacabare. For more information, you may reach out to our website or through PeeringDB, or you may reach out to our email, sales.keyaccount@napinfo.co.id. Thank you.
Okay, thank you. Could you? Okay. And also we provide you the data centers. We have 3 locations in Indonesia, which is a Matrix data center in Batam, Nongsa. Also Matrix data centers in JK2, Cyber One, Jakarta. And the last one is Matrix data center. This is the latest, our data centers, which is MDC JK3 at Plaza Kuningan. For the IXS presence, we do have our IX in MDC JK3, in Indonesia IX and Matrix IX. Our ISN presence is in Cyber One. There's more than 30 ISNs, and in our latest data centers, we have more than 20. Please check out our PeeringDB at below. And if you have any further questions, please feel free to buzz us. Thank you.
Thank you.
Okay, so actually
one
I
more.
haven't.
Actually, you have
Yeah, sorry. Okay, for peering, you may reach out to our AS number ASN 55818. We are available on multiple locations across Asia, Europe, and US. Feel free to reach out to the PeeringDB, and you may reach out to our email peering@napinfo.co.id, which will be helped by our colleagues Safira and Nisa. Okay.
Yeah.
Okay. Thank you.
Thank you, Clara and Hannah. Next, we have for the additional IXP, we have AMSIX.
Thank you. So we are M6. It's Petra, Steven, and I'm Onno. And we also have Ruben here, who is our CTO, but he's in the meeting somewhere. But we operate exchanges worldwide. And here in Asia, we operate exchanges in India, in Hong Kong, in Singapore, and pretty soon also in Bangkok, and possibly more locations will follow. So I will hand it over to Petra.
As you have noticed, we have a stand here as well, so come and reach out to us there. Furthermore, AMSIX is also one of the organizers for the European Peering Forum, Global Peering Forum, and our own More IP event. So if you want to learn more about these events, please visit our booth. That's it.
Thank you.
Yeah, thank you.
Thank you. Next, we have Mega IX, Gavin.
Afternoon. I think I'm the last one. I'm Gavin Tweedy from Megaport. We operate Mega IX in several countries and ECIX in Germany. My colleague Colin is here as well as Gerald. Catch us at the drinks if you're there tonight and have a chat.
Thank you, Gavin. So that concludes our peering personals for today. Thank you.
Thanks again. Thanks, Marlon. As promised, we have a generous sponsor who will do a raffle based on PHNOG tradition. Yes, they said only those who are physically in the room will win the prize. You can drop your whole box of cards here. It's up to you. We'll draw from another box anyway. So I'll hand over to my colleague Richie, who will manage the raffle.
Oops, sorry. Has everyone already submitted their call cards, or you can actually put, if you don't have any call card, you can write on a piece of paper your name, company name, and contact info. So we will be having 6 winners for today's raffle.
So for our first winner for our Belkin Boost Charger, may I call on Achi to draw the winner? Draw.
Sorry, not paying attention.
Hey.
So for our first winner, so presence is a must. Our winner is from Interland, Eric Andre Balinu. Congratulations.
Thank you.
Our sponsor for the first raffle draw is GXC, Global Cloud Exchange. You're in the middle. Thank you. For our next winner, again from Global Cloud Exchange. Winner is from Globe Telecom, Mayan Ramirez.
Tanong mo kung may disagreement.
And she is asking if there's any violent reactions on the winner.
Eh, teka lang tayo. Ruminak lang natin. Saan ba siya? Okay, sir.
You do.
Our third raffle winner for Dashcam Pro Plus and rear cam set for your vehicles. Ooh. It's from National Telecom. It's Nilubol Baru Butikil. Vitikul. Did I murder the sorry? Congratulations. Thank you. And for our last two winners, we're giving away a wireless air cleaner diffuser from Source Telecom. And our winner is Sandeep Shetye from Control S. Congratulations. Thank you. And for our last winner for today, another air diffuser from Source Telecom. From Conversant, John Paul Pangilinan. Since presence is required, we'll draw another winner. There's no company name, but the winner is Andy Baulete. Okay.
Congratulations. Thank you.
Thank you.
Thank you.
So
Thanks again. Please don't go yet. We have one more announcement, but before that, I would like to invite you to stay until the closing because we'll be raffling off a MacBook Pro. I would like to call on Toyama-san on the stage for updates on Peering Asia and GPF. Want to jump? Thank you, sir.
Yep. So, yeah, so everybody already a lot of time has been passed, but then please do not go out the room. I thought I was skipped. Oh, I would like to talk about an announcement on the Peering Asia. Okay, so the next slide, please. So do you know the Peering Asia? Maybe you are here, so you know a lot about the Peering Asia. So next slide, please. So this is Peering Asia is an open and a neutral or peering event, like in a GPF, EPF, LACX Peering Forum, and AFPIF. And Peering Asia, you know already, we have an 4 in-person event so far. Okay, then please go next. And the last one that was held in the last November, hosted by the Thailand IX and BBIF. Thank you for the host. Please, next. And that was attended 271 and S1 and 137. So, still in the COVID, yeah, but in a substantial number, yeah. When attendee we had, okay. So, this is in the pictures. Yeah, thank you very much. I think you've enjoyed that. So the Peering Asia 5.0 for this year, that is in Seoul, Korea. Okay, so hosted by Kings. Oh, is there any Kings guy here? No? No? Oh, that's unfortunate. Yes, I already introduced and instead. Okay. So the venue is in the Silla Hotel. Oh, that is in a very premium hotel, I've heard, and on the top of the hills. And that is in the not so far from the airport. They have a good transport. And this is a venue, very traditional, the Korean architecture and yeah, and the meeting rooms. Okay. So we're waiting for you at Seoul. That is in November 1st and the 2nd. So please mark your calendar. And now we'll start to the business trip plan. Okay, so we're waiting for you at Seoul. Yeah. And one more thing. Yeah, you know also the Global Peering Forum. And also I am a board member of the GPF. So I would like to announce that GPF is 1 month away. So, and this time we will have a GPF in the San Diego, the west coast of the USA. So relatively easier for you, for the Asian people to go to US at a place. So the registration is ongoing and more than 100 people are registered. So please see the attendee list and registers, please. Okay, so that is a short announcement. So see you in GPF and Peering Asia 5.0. Thank you very much.
Thanks again, Toyama-san. And to close this session, the next activity will be the Peering Socials, but it's an invitation event, so make sure you have that so you can go in at the bar downstairs. For tomorrow, we start again with a couple of sessions in this room, the diversity session. And then we have network ops, internet technology, and NOGBOF and NOG reports tomorrow. See you again, and thank you.